Welcome. My name is Ron Papa Schmidt, and I'm the creator of the Net Zero Now YouTube channel. This is going to be video 3, and the title is going to be, how do we know? Building the Climate Network. You're probably asking yourself when you see some things like I do, okay, so somebody comes up and says, here's what the average global temperature is. Well, how did they come up with that number? They have a single number for the entire globe. How do they figure that out? That average, all this stuff, how does that work? Or you see climate models out there saying, projecting here's what's going to happen and things like that in the future. Well, how do these models really, where do they get their data? How do they account for the behavior of Earth's climate systems that we talked about in video 2? Or other things. And since, if you think about it, climate is kind of a global thing. No individual country has their own unique weather system. Okay, we're all interconnected on this planet. Well, so you really need to know what's going on globally if you're going to be able to predict what's happening to your local area. Well, do nations really share data actively? And resources, or do they keep them proprietary? I mean, how does that work? If they do share data, how do they manage that across you got all these different languages, different locations, different kinds of technologies, varying formats, different time zones. How would you possibly manage all of that? And in fifth, since a lot of the things we do require global knowledge, like aviation, marine shipping, weather tracking, and other kinds of things. How do these complex systems function? How do they operate efficiently? And those are the kinds of questions we're going to address in this video. And when we talk about the climate network. In this video, if you looked at video 2, that was a pretty dire video. There's some serious subjects we talked about here. This is sort of like a lighter video, if you want to call it that. It's just sort of, it's designed to sort of explain how this stuff works. It doesn't require heavy concentration. You don't have to remember things and other kinds of things. So just sit back and enjoy this video. I think you'll find it very, very informative. I know I was just blown away by how sophisticated the world's efforts are in this area, and I think you will be too. So why don't you just join me on this journey, and I'll try to walk you through that at a pretty high level, what's going on. And so you can get an appreciation for when you see numbers about temperatures and other kinds of things, what's the raw data like? Where are they getting that information from? So the key player in this happens to be an organization called the WMO, or the World Meteorological Organization. And they coordinate international standards and communication networks that link thousands of satellites and ocean buoys and weather balloons and land stations and all this together into a single, seamless kind of global system. Okay, so who is the WMO? Well, number one, structurally, they are what they call a specialized agency of the United Nations, but they operate completely independent and have autonomous authority, okay? They were created in March of 1950, and they were established by their own sovereign treaty. They are an independent organization, and they were established in what's called the WMO Convention. And they have an independent governance. And so what that means is that there is an organization called the WMO Congress, which is made up of its member states and territories. And by the way, there are 193 of those. And they're the ones that determine they determine the funding level. They determine how this organization runs. The UN cannot appoint the head of the WMO, dictate its budget, or vote on any of its scientific policies. They are really, truly an independent organization. So the next question you're probably asking, well, how do they fund it? Well, every 4 years, the WMO Congress, and that Congress is made up of WMO members, they meet to approve a budget. And with the budget, this core budget sort of covers the day-to-day administration of the WMO, which is located, the Secretariat office is located in Geneva, Switzerland, and the cost of governance meetings that establish international standards. And by the way, the staff is relatively small. There's only 200 people there, basically, or roughly around that. In terms of funding, they're funded by via mandatory assessment invoice to every member country, and the amount is determined by a formula that they've agreed upon. And then in addition to that, there are periodic voluntary funding projects where the WMO coordinates massive multi-million-dollar international development infrastructure projects. Now, these are all done through a voluntary basis, and there are extra budget donations that come in for that. And what they're designed for is that some countries are very poor, and they want to, if we want to put up sophisticated measuring stations in those countries, they just don't have the resources to do that. So the WMO will come in and do that. In other cases, you may have some stations in remote locations like Antarctica and the Tibetan Highland Plateau, rather, etc. And there's other remote locations. So where they want to have more, when they want to put in some sophisticated devices, particularly at the poles, what they do is they basically say, here, we need to, this is a weakness we have in our system. Let's all contribute money to make that happen. And that's so they have voluntary efforts to do that. Now, this is what the network looks like. Now, if you have a cell phone or a tablet, you probably can't read any of this, okay? And that's really not all that important. Let me just sort of explain it to you briefly. So what you have is you have inputs, and we're going to talk about 10 major sources of input. And this input comes in real time. And it comes into then generally what they call national centers or local areas. Those local areas then send the information to regional areas where it's condensed. And then they, at each one of these levels, they also do some quality control to make sure that the information they're getting seems reasonable. And then the regional centers upload that information into what they call 15 super hubs. And these 15 super hubs are located in major cities around the world, and they all connect and communicate instantaneously. So when data is uploaded in the system, almost real-time basis, it's shared on every one of these systems around the world. And that's basically the structure. Now let me say one other thing. All of this equipment is funded by individual countries. It's not funded for, paid for, or operated by the WMO. It just acts as a coordinating manager of these systems. So let's get into the data sources, the data it collects. We're going to cover 10 major sources of data. The first one is what they call standardized terrestrial weather stations, sort of land stations. You see an illustration of it there. And these weather stations around the globe, there's over 10,000 of them. They basically communicate information into the network every 15 to 30 minutes, depending on where they're located. If they're located near an airport, it may be every 2 to 5 minutes or something like that, just to make sure, because of the safety concerns about everybody understanding what's happening with regard to weather conditions there. And they're located on all 7 continents around the globe. The next area is we have synchronized weather balloons. Now, I knew we had weather balloons, okay? I didn't know that there were 800 of them. They're located around the globe and at locations that do this, and they send these weather balloons up twice a day. And these weather balloons, as they're going up, every 1 or 2 seconds, they report back to the central hub on a real-time basis during their entire 2-hour climb into the stratosphere. The next thing, there's something they call the Argo network. They're automated deep ocean floats. Now there's over 4,000 of these. Now these are also kind of interesting devices, okay? What they do is basically this float, it goes down to about 1,000 meters. and it floats there for basically 9 days. And then at the end of 9 days, it goes down another 1,000 feet to I should say meters to 2,000 meters. And then what happens, it ascends. As it ascends, it takes it about 6 hours to get to the surface. And why it's doing that, it's constantly sending back information about the water, its temperature and other profile information. It gets to the surface. It transmits its information to a satellite network. And then once it's done with that, it sinks down to, again, 1,000 meters and then floats for another 9 days. Who knew that there were 4,000 of those things around the globe, okay? Jets, commercial jets, cargo planes, etc. A lot of them have what they call the AMDAR network, or commercial aircraft sensors. And basically what they do is they transmit information real time. They take measurements, okay, such as wind speed, pressure, etc. And so when the jet's ascending and descending, it does that maybe every 10 to 30 seconds. And then when it's cruising at high altitude, it only does it every 3 to 7 minutes. So that's going on constantly around the globe. The other thing is, then there are satellites these are weather-specific satellites that are tracking and reporting information real time from around the globe. And there's just a number of those. We'll talk about that in a second. And then you have ships. And these are sort of on a voluntary basis. Commercial vessels, research ships, cruise liners, etc., and stuff like that, have automatic sensors in their hull. And every 6 hours, they in turn transmit information to this network. Then on top of that, you have moored and drifting ocean buoys. And there are also hundreds and hundreds of those. And those are basically, a lot of those are on the sea of the ocean, some float on the surface. And one of the primary things they do, they help us determine when El Nino and La Nina cycles are going to occur. And these moored buoys really transmit information every 30 to 60 minutes. And then you have radar stations around the globe that transmit information basically about every 4 to 6 minutes. Then on top of that, you have some at high altitude and polar observation baseline observatories. These are permanent structures that are created to exist in sort of extreme environments like the Tibetan Plateau, the Greenland ice sheet, the deep Antarctic interior. And they capture all kinds of important information like baseline greenhouse gases concentration and other things. And then you also have, in addition to that, you have these specialized networks. Some are put into areas where there's deep permafrost to track that. Some are on alpine mountains to correct snow, to sort of be able to tell snow depth. In urban areas, you have some microclimate grids that may exist. So here's another slide. I think this is interesting when you look at it because it just shows you the level of global cooperation between the superpowers in terms of what's going on here. So if you take a look at satellites, you have 14 United States satellites, 11 Chinese, 5 Russian, 10 from the European Union, 3 from Japan. There are other ones. They all transmit information into the same network. They all work together. And these satellites and everything you see here is owned and operated by these individual countries. But because they recognize the value of having shared information, because we all live on the same globe, and these are global systems, they've agreed to basically share all this information real time. And you can see over land stations, the United States is over 1,000, China 2,400, Russia 1,600, EU 4,500, Japan 1,300, and there are other countries involved too. It gives you a sense of the scale. Same things with Here's some of the where some of the balloons, 800 balloons that go up every day, where some of those stations are located. Here's the Doppler radar stations, and so where some of those are located in these different countries. And then you have the ocean buoys and Argo floats. So what I want you to get a sense of here is look at the countries that are involved. Frequently, there are aggressive competition with each other and not known for working together, okay? And yet they're working together to do this in a massive way, and they all own their own equipment. But they're choosing to share the data. So the next question is, so this is the network. You can see now, if you look at that same slide again, you can see the 10 sources of data coming in. You can see how this network, how they share that information. So how do they make that work? So now let's get into the WMO and its infrastructure. Okay, so the WMO, we told you, was located in Geneva, Switzerland. There's their building. Basically, they have a small staff of about 200 people. And their role is really sort of administrative. And then also they have a bunch of scientific and technical coordinators. So they're an administrative coordinator. They're responsible for creating standards, managing standards, quality control, protocols, data transmission, software design, etc. Now, that's done. Obviously, if you have 200 people, you can't do a lot of that yourself, okay? And so they have these different organizations then that play a vital role in how this system works. Because their model is they're the coordinators. Individual countries assign experts to work with them under their control and direction to do all these different kinds of tasks. And so let's get to the first body, number 2, the WMO Infrastructure Commission. And these are the guys that are sort of the technical body within the WMO. They're the ones that help design all the stuff. They define what the calibration intervals are going to be for equipment, what the housing rules are going to be, what error checking, how do you check the information coming from all these different stations around the world. As you can imagine, we just saw 10,000 of this, 5,000 of this. You've got to have all kinds of problems constantly in all these locations around the globe, right? How do you make sure that we're getting information? How do you resolve problems? How do you deal with technical issues that arise, etc.? That's their job, creating these kinds of standards that is going to work. And these commissions are all made up of experts from these different countries, and they get together and figure out how they're going to do that and agree on the standards and other kinds of things. And that way you know that it's sort of, you have a thermostat in Siberia, it's accurate, it's reading the temperature the same way as Siberia is, or as the sensor is on the Boeing 777 or a radar station, etc. They're all speaking the same digital language. They're all able to share this information, etc. So that's what that body works on. The next body is something they call the WMO Integrated Global Observation System. And these guys are basically the hardware managers, okay? Because look at all, you can see here, I just showed illustrations again of the 10 data sources. You can see the different kinds of technologies and hardware and other things that are involved. And you just imagine these things listening, all over the globe, where different time zones, different languages, different companies constructing this stuff, etc., etc., etc. Well, how do you make sure that this stuff all works together and it produces accurate data and other kinds of things? And how do you synchronize, these streams into a cohesive functioning system? Well, these guys look at this from a hardware perspective, so they may create the hardware standards and other kinds of things that necessarily make that stuff happen. Then we have the next group that's involved is the WMO information system. So this is another group thing. Again, these are coordinated by the WMO, but the staff members here that are doing this come from other countries, and they're assigned specifically to work in this particular organization, and they're paid for by their own countries. And so if you've seen this network, I don't know. I mean, I spent my life, or not a portion of my life, designing and managing information systems. And I did that in banks in local areas across countries, and later in JP Morgan Chase a little bit around the world, a little bit like that. That's all one company. And let me tell you, the complexity that's associated with making that happen is just immense, okay? Now, here you're talking about using people from different countries that are normally maybe their bosses are, or the politicians in those countries may be at war, but yet they're able to work together to do this. They're the ones that do the programming for this network. They're the ones that design the software, test the software, make sure that it's working, and the code is originally being developed potentially in different countries. But it gets together, it goes through a review and testing kind of process. And so that's how this thing works. They're all running the same software and stuff, and it's all developed by the WIS, but it's really funded for, paid for, and the development work is really being done by the individual countries. I mean, that is just an amazing effort. And to me, it's just incredibly impressive. Now you have a three-tier network here too. So this has to work both on the original hardware. It needs to work in the national hubs. It needs to then work, and they need to be able to quality control the data. And then it goes to regional hubs, and they need to be able to quality control the data and be able to process it before it gets fed to the supercomputer centers, which then in turn instantly share the data with the other supercomputer centers located around in different countries around the world. So there's basically 15 of those. That is the WIS, and that's how that works. That is the backbone of a lot of what's going on here. Then the other thing you have is they have the WMO integrated processing and prediction system. And think of this as really sort of a data control system. I mean, you can imagine all these different things out there. There's going to be constant problems coming up. So, and one of the things you want to make sure of is you don't get bad data getting into the supercomputers, okay, into that network. So you have to be able to figure out, well, does this look reasonable based on the last results we had and other kinds of error checking, so they can basically scrub out these local errors so it doesn't pollute the global number. So this group's responsible for creating those standards and making that stuff work. And then lastly, you have sort of the 15 global information computer centers. These, again, are all located in the different countries, are funded completely by those countries, staffed by these countries, etc. And there are cities like, Washington, D.C., Beijing, Moscow, Tokyo, etc. Now, you want to make sure that these systems are all following, though, your international standards that you've all agreed on. And so the WMO basically role here is to really go in and audit them and make sure that they're following the standards that they both had participated in, creating them, help define them, or implementing them. You want to make sure now that they're following, and sort of that's what this group does. So that's basically the WMO and how it works. So let me just summarize this again, okay? I mean, if you look at this, the comprehensiveness of this, the complexity of it, and how efficiently it runs is just mind-boggling to me. I knew we did some things to get to. I knew we had balloons. I knew we had satellites. I knew we had these other things. I really didn't understand how integrated they were and how cooperative all these different countries are to putting this together. I mean, this is really, it seems to me, if I were looking at it and give it a grade, I can't think of a better way or a more efficient way of doing this and also ensuring that you have quality throughout the network because everything here is open. It's open source code, it's open data. Everybody can look at what everybody else is doing, which adds to just the integrity of this process. And the other thing I'm impressed with is how they go through and try to verify all this information, how they try to make sure that all this different hardware is working and communicating with it, and how they try to make sure at every level that the data they're getting is accurate. Because when you have that much stuff operating in these many different locations, there's got to be constant problems all the time. So how do you keep that out of the system? I mean, nothing is foolproof, but this is about, from a conceptual standpoint, it's about as good as you can get and probably the most efficient way you can go about doing this. I was just super impressed from somebody who's worked in this area for a long time, okay? And there's absolute scientific transparency, which is the other thing. This is a verified data network, and it provides, I think, just an overwhelming confidence in reporting because everybody's doing it. Everybody can see what everybody else is doing. They check one another's work. And so I think that gives me personally a lot of confidence. And the resulting global mosaic that's coming here, I mean, these aren't statistical estimates or political guesses. These are meticulously validated physical records of change to our atmosphere. And I think if you see how thorough this is, hopefully you come away with that same sense. And this is a piece that gave me great optimism. I mean, if you've watched the Titanic table thing, that can get really kind of depressing. But this gives me optimism, and I'll tell you why. This is a real-world example where adversaries around the world are working together and have consistently for a long period of time, about 75 years or so, and have done that in a very cost-effective way. And they've continued to do that even when there have been constant global conflicts going on. And they've done it in a way that is verifiable, efficient, etc. And so the next thing you quickly come to is that, so if we look at so many things that require sort of global cooperation on things, you look at our political leaders and you say, oh, it ain't going to possibly happen with this group of people we got running these different countries. But here, this is proof that it actually can. And so if we really have the commitment to do something, like here we do, because it's in everybody's best interest, right? So that tells you the real barriers are not technological. The real barriers to doing cooperation isn't that we don't know how to do this, or we can't do it, or economics. As you can see, we figured out a way of funding this complex thing. It is really fundamentally political will. So to me, that's encouraging. And the other thing is, if you take a look at, if you listen to any of my things, I urgently continue to say we need to get to net zero greenhouse gases now. And you ask yourself, how is that possible? I mean, look at all the countries that have different airplanes, different modes of transportation, different shipping, all of these things. I list 100 different things. Well, this tells you that it's really possible if we wanted to. You could set up a different group within each, name a problem. You could set up an international group to go deal with that problem and come up with solutions to get the net zero greenhouse gases. We could follow this blueprint, and it's proof that it can happen in today's world. You can do it in a cost-efficient manner, and it really works. And so that, to me, is encouraging. So let me wrap this up real quick. You've seen the Titanic table before. I'm not going to go through it again. I just want to say The reason I wanted to go through this, when you see these numbers on that table, I want you to know what's behind them and how we got there. And so when they talk about an actual temperature number or projection numbers or other kinds of things, this is where they're getting the raw data. And as I look at it, I'm really impressed with the quality of it and that information, which says then the results coming out of it, we can trust. So let's do my normal closing here. Okay, so recap, what do? We talked a little bit about the WMO, its infrastructure, its operation. We reviewed how global climate data is collected. And we discussed how the WMO could maybe provide a blueprint for a fractured world. B is, and this is the message I give in everything, is the only way, and I mean the only way we are going to avoid a climate disaster is we need to get the net zero greenhouse gases now. Now, I don't care what the solution is, okay? It doesn't mean we have to shut down every coal plant or do this or do A, B, C, and D. But so if we decide coal plants are necessary for a while, fine, then we need to figure out some other way of cutting greenhouse gases to net zero. One of the sources could be planting more trees or doing some other kinds of things. It doesn't matter what individual choice you make, you just need to make sure in aggregate we're getting to net zero. If we don't get the net zero, it doesn't matter. We solve 6 problems, we don't solve the other 4, and we don't get the net zero, you get the same result. So we just need to get the net zero, and I don't care how we get there. Lastly, I would say this is happening fast if you've listened to video too, and if you haven't, please look at it. What are you going to do about it? I guess I'll ask you to vote, subscribe, share this link, talk about it, get involved. Your future, your kids' future, your grandkids' futures depend on it. And I hope you'll join us for some additional videos here. The next one I'm going to talk about how they actually go ahead and calculate actual temperature for the globe. You'll find that even more fascinating than this is. And then also how they do climate projections. It'll be the next 2 videos I'm going to do. So thank you for your time and have a great day.